Hello, so in this video I will be going over conversions from binary, decimal, octal, and hexadecimal conversions. So first I will do a conversion from decimal to binary and then from binary to decimal. So the very first thing I'm going to do is I'm going to list out my powers of 2 table just because that is very helpful and important when doing a conversion. And the table goes from 2 to the 0th power all the way to 2 to the 9th power. So I'm just going to list out my table. Oh, sorry. 16. So for this example, I'm going to pick the number 223, and this is in decimal number. So in order to convert from decimal to binary, you need to start dividing the number by 2 and then listing out what the answer is and if you have a remaining value. So 223 divided by 2 is equal to 111, and you have a remainder of 1. So I'm just going to list that out. And then I divide my answer, which is 111, by 2 again, and I will get 55 with a remainder of 1. Then I will divide 55 by 2, which gives me 27 with a remainder of 1. 27 divided by 2 is equal to 13 with a remainder of 1. 13 divided by 2 is equal to 6 with a remainder of 1. 6 divided by 2 is equal to 3, and this has a remainder of 0. Then 3 divided by 2 is equal to 1, and this has a remainder of 1. And then 1 divided by 2 is equal to 0 with a remainder of 1. So in order to do the proper conversion to binary, you have to move up the table. So first I'm going to list the number that's here at the bottom, and I will be moving up the table this way. So the first remainder that I have is 1, 1, then 0, then 1, 1, 1, 1, and 1 again. So this is the conversion. So 223 in decimal is equal to 1, 1, 0, 1, 1, 1, 1, 1 in binary. So for the next example, I will convert from binary to decimal. So I'm going to be using the same powers of 2 chart, but to make it a little bit easier, I'm going to rewrite the powers of 2 table horizontally. So I'm going to write 512, 256, 128, 64, 32, 16, 8, 4, 2, 4, 2, and then 1. So I'm just going to write out a random number. Down here, I'll just do 1 0 0 1 1 0 1 0 1. Okay, and I'm going to be moving from the left side of the number here, and this is the first number that I'm going to look at. So this one here is going to go in the beginning of the table. So it's going to go here where the 1 is. So 1, this is a 0, it's going to go here, and so on. So I'm moving from the back of the numbers to start the front of the table. So I have 1 0 1 0 1 1 0 0 1. Okay, and now I'm just going to write out all the numbers that have the 1s on here in the table, and I'm going to add them all together. So the numbers that have 1s are 1 plus 4 plus 16 plus 32, and then plus 256. And I will just plug that into the calculator very quickly to get, let me see, and I will get an answer of 309. And again, this is in binary and this is in decimal. So from this conversion here, I have that 1 0 0 1 1 0 1 0 1 in binary is equal to 309 in decimal numbers. Okay, so now I will be converting from binary to octal, from octal to binary, from binary to hexadecimal, and from hexadecimal to binary. So the conversion table between binary and octal goes from the number 0 to the number 7, and the conversion table from binary to hexadecimal goes from the number 0 to number 7, and then from the letter A to the letter F. But to make it a little bit easier, I will just be combining them into one table. So now I will be doing a conversion from binary to hex, and then from hex to binary. I'm just going to start off with a random binary number. I'll just do 1 0 1 1 1 1 0 1 0 1 0. So when doing conversions to hex, we're actually going to use all 4 rows. So we need to split this up into numbers of 4s. So I will take 1 0 1 0, and then I will do 1 1 0. And again, I am missing one number at the end because I only have 3 numbers, so I will add a 0 to the end of that as a placeholder. So working from the back of the numbers, I'm going to look at my table to see what matches 1 0 1 0. If I look at my table, what matches is the letter A. So the 1 0 1 0. So I will write this section as the letter A. I will look back to see what matches with 1 1 1 0, and that looks to be the letter E. And then with 0 1 0, that looks to be the number 5. So I have that this number in binary is equivalent to 5EA in hexadecimal. So now I will try to convert something from hexadecimal back to binary. So here I will just do EA8, and I'll do one more. I'll do C. So EA8 and C. So again, I'm going to be starting off with the last part of the hexadecimal number that I have. So C in the binary table is 0 0 1 1. 8 in the binary table is 0 0 0 1. A is 0 1 0 1. And then E, let me move this, I'm running out of space. E is 0 1 1 1. So I have that EA87 in hex is equal to 1110 1010 1000 110 in binary. And that is it for the conversions. So the way that this table works is we're going to have 4 rows listing out the binary numbers. So the first row will alternate 0, 1, 0, 1. The second row will double in 0, so it would go 0, 0, 1, 1, and then it would keep on doubling. So this first row is 0, 1, 0, 1, 0, 1, 0, 1. So the second row doubles, so we have 0, 0, 1, 1, 0, 0, 1, 1. And then this next row doubles again, so we will have 4 zeros, 4 ones, okay, then 4 zeros again and 4 ones again. So the next row will double once again, and we will have 8 zeros and 8 ones. Okay, and so here is the table. So I will start converting from a binary number into a octal number. So I'm just going to write out a random binary number. So I have 1 1 0 0 1 1 0 1 0 1 0. Okay, and so this goes by pairs of 3 when you do octal conversion. So I need to split this up into pairs of 3. So I have 1 2 3 1 2 3 1 2 3, and because I only have 2 numbers remaining on the last end, I'm just going to add an extra 0 as a placeholder here. So, and again, this is in binary numbers. So starting at the back, 0 1 0, I'm going to look at what in my table has 0 1 0. So what has it here is the number 2. So if I zoom in, you can see this is 0 1 0, and I'm only using the first 3 rows of the table just because I'm doing octal conversions right now, so I don't need to use the 4th row. So I'm going to use the number 2 for this. Then I'm going to look to what has the number 1 0 1, and that actually looks to be the number 5. So this is 5. Then I will look for 0 0 1, which is the number 1, and then for 0 1 1. In 0 1 1, it is the number 3. So the octal conversion to this is 3 1 5 2, and this is in octal. So then if I want to move back and I want to do, if I want to move back and I want to do a conversion from octal to binary, I will just pick a number ranging from 0 to 7. So I'm just going to do 7 6 0 2. 7 6 0 2. So I will look to where the number 2, I'm starting at the back of the numbers first, and then I will move towards the front. So I will look at my table and see what the number for number 2 is. And for number 2, it is 0 1 0. For 0 is just 0 0 0. For 6, it is 0, 1, 1. And for 7, it is 1, 1, 1. So this number in octal is 1, 1, 1, 1, 1, 0, 0, 0, 0, 0, 1, 0 in binary.